Firstly, I would like to define files. Files are collections of data created by users. For a user, the most important parts of OS include file system. It provides a means to store data organized as files as well as a collection of functions that can be performed on files. Desirable properties of files include long-term existence, which means that files are stored on disk or other secondary storage and do not disappear when a user logs off. Shareable between processes, which means that files have names and can have associated access permissions that permit controlled sharing. Lastly, structure. Structure refers to files being organized into hierarchical or more complex structure to reflect the relationships between files. Typical file operations include create, delete, open, close, read and write. Commonly used terms when files are being discussed are field, record, file and database. Field. It is the basic element of data. It contains a single value. It is of fixed or variable length. Record. It refers to a collection of related fields that can be treated as a unit by some application program. File. File refers to collection of similar records. It can be treated as a single entity. File may be referenced by a name. The access control restrictions usually apply at the file level. Lastly, database. Database refers to collection of related data. The relationships among elements of data are explicit. Database is designed for use by a number of different applications. Database consists of one or more types of files. File management system objectives include data management needs are to be met to guarantee that the data in the file are valid. Performance should be optimized. Provide I/O support for a variety of storage device types and providing I/O support for multiple users in case of multiple user systems. The file system architecture has layers which includes file organization types, namely file, sequential, indexed and hashed file. Also the other layers include logical input output, basic input output supervisor, basic file system and device drivers, namely disk device driver and tape device driver. Let us discuss about device drivers. Device drivers are the lowest level in the layered file system architecture. Device drivers communicate directly with peripheral devices. It is responsible for I/O operations on the device. Device drivers also process the input-output request. Now let us know about basic file system. Basic file system is also known as physical input-output level. It deals with blocks of data that are exchanged with disk or other mass storage devices. Also we have logical input-output. This level is the interface between the logical commands in a program and the physical details required by the disk. Thank you. My teammate Prashant would continue from here.
Hello, my name is Prashant and I will continue the lecture from here. My part of explanation focus on types of file organization and access. However, there are several criteria that are important while choosing a file organization. Let me mention a few. Short access time. We need short access time when we try to access a single record, and it may not be necessary for a batch node. and the second one is ease of update. This is self-explanatory. It says that updating of a file system is easier, should be easier. Okay, economy of storage. It depends on how minimum we can keep the redundancy in data. But we also need redundancy because redundancy helps us in indexing, and indexing helps us in accessing the file faster and easier. And simple maintenance. The maintenance of the organization, the file system should be simple. Okay, let me tell you the file organization types. Indexed file, direct or hashed file, sequential file, indexed sequential file. Okay, let us go through one by one. File. It is a file organization type with minimum complexity. It just piles up the data into the records. You can see the diagram towards the right. It says it employs variable length records, variable set of fields, or chronological order. The main purpose is that the saving of the files is easier. Okay. Sequential file. It has common file structure and uses a fixed format of records. The keep field uniquely identifies the records and determines storage order. It is the only organization that provides us the flexibility to store records on tape as well as disks. But the thing is, it uses fixed length records, fixed set of fields in fixed order, sequential order based on key field. Okay. Indexed file. Indexed file. Primary goal of indexing is records are accessed through indexes, which makes accessing easier and fast. Indexed file system employs variable length records, and it's mostly the main examples of indexed file systems are airline reservation systems and inventory control system. The basic idea behind this is that timeliness of information is crucial here. Okay, indexed sequential file. It eases the access of records by maintaining the indexes. Multiple level of indexing can be used and it makes it more advantageous. Direct or hashed file. If any address of the block is known, we access it directly by giving it the key value. The organization hashes the key value and utilizes it. I have mentioned a few examples in the rectangular box on the right. Also, I mentioned here when we can use direct or hashed file. When very rapid access is required or fixed length records are used, records are always accessed one at a time. Okay. File directory information. By reading the chart, one can observe that the information is biased depending upon address, access control, and usage. First, I have given the basic information. It depends. The file system is considered about file name, file type, and file organization. And the address information, it considers the volume, starting address, size used, size allocated. And access control information, owner, access information, and permitted access. Usage information, date creator, identity of creator, date last read access, identity of last reader, date last modified, identity of last modifier, date of last backup, and current usage. While we observe the information is biased on different criteria, the basic address, access control information, and usage information is clearly picturized. And my friend will continue the lecture from here.
Hi, my name is Ramu Kamagineni and KID is K00034416. I'm going to discuss about different operations on directory as well as files. What are the different operations performed by the files and directories? We have copy files is one of the operation performed on the files. Copy files is the operation copy the data from one file to another file, as well as remove directory and create files and delete files, list directory as well as update directory. These are the operations we have to perform on files as well as directories. And overall at the end, the operations used to manage the files and directories. And next I'm going to discuss about two-level scheme. Is a scheme for the files and directories. Files and directories have some limitations and controls as well, and for the users and well as the groups for the files and the directories. Here we can see one of the limitations. We have several limitations. Names must be unique only within the collection of files of a single user. Names must be unique in this option. And second one, file system can easily enforce access restriction on directories. And second and third, each user directory is a simple list of files of that user, and there is one directory for each user and a master directory. And the end and the last, the master directory has an entry for each user directory providing address and access control information. These are the limitations and control options for the files and directories. And next here we can see the tree structure directory for the master and subdirectory. For example, in this diagram we are creating multiple subdirectories under master directory. So under master directory we can create multiple number of subdirectories. Under that we can create files, number of files. So for example, we can create Ramu under R1, so something like that. And each user directory may have subdirectories and files as entries. And next we can discuss on access rights, different levels of access rights for the users for the files and directories. Here we can reading and execution and knowledge. These are the different levels of access rights, and updating and appending and changing production and deleting. Reading is the accessing for the file. He is going to reading, opening, viewing and copying the file is allowed. And come to the writing and changing and deleting and saving the file is allowed. For the execute and invoking the files allowed. This is required for the directories to allow searching and access. These are the different levels of access rights for the files and directories. And comes to the user access rights, we have owner and specific users and this user groups and all. These are the different levels of users, and each level there is own limitations and controls for the files and directories. For example, owner, he have full rights, and specific users in this level there is own individual IDs, user IDs. And next, user groups and set of users who are not individually defined. And all means all can access for the particular files and directories. And here we can see different levels of access controls. And for example, in the system you can run multiple users. It's important to protect one user subject as well as files and directories. Here we can see two levels of protections. For example, logon verifications and access determinations. Access determinations means permissions to access a specific object, and access matrix is one of the technique to determine access rights. Here we can see the diagram. Here different levels of files and different levels of users. Here we can see user A and B and C is the different users, and different files we have file 1, 2, 3, 4 and do accounts 1 and 2. Here we can see file owner is the user A, file 2 is the owner is user B, and file 4 owner is user C. Here we can see the options read, write and execute. Okay, read, write, execute, these are the different permission levels on for the files and directories. Here we can see basic elements are access right and object and subject, and this is the access matrix. This is one of the technique to determine the access rights. So, and here we can see Unix file, Unix operating system, how file access control is managed and controlled. Here we can see different levels of classes. We have owner class, group class and other class. Here we have users permissions and group permissions and other permissions. This is a Unix approach, and as well as extended access control list means read, write, execute. These are the user level and group level and other level permissions. And we have the permissions are categorized into three groups who have or do not have the permissions. The file owns the group, and everyone else who have access to the server referred to as others. For example, I'm going to give all the permissions to the all, means 777, means we have a read, write, execute all permissions. 421, 421 is a 3 by 3 array follows or groups. And next Prithvi will continue. Thank you.
Hello sir, my name is Prithvi and my KID is K00336409. Right now I'm dealing with the topic of file management, and in this file management previously my friends has discussed a few set of access controls and organization, file organization, so different sort of issues. But right now I'm going to deal with the main core part like file allocation techniques. Without this file allocation, the file management isn't completed. So the file allocation techniques basically, it's kind of a name itself says allocating, file allocating. So the voice is gonna be taking care of all these things. So it gonna be has some sort of a better algorithm, better program to save such a kind of a file into a hard disk and easily retrieve it. So the basically the allocation is kind of very hardest thing, because there are a couple of issues suppose if the user writes a data, if user has the data, some sort of a text file, if you want to save it on the hard disk, the O is going to be take caring. So the best allocation algorithm is needs to save the memory space in the hard disk and gets the best allocation way it's going to be allocated and easily retrieved, so that the seek time must be less, so that retrieving of the file is going to be less. So there are the many sort of criteria while developing in these type of file allocation algorithms. So right now whereas talking about the hard disk, the disk is kind of divided into the physical blocks, very commonly referred as them as the sectors or the tracks right now, and there are the file allocation table also for these type of an algorithm. So where they're gonna be maintaining some details of the files. Those details we are going to see as soon as possible right now in these slides. Okay, whereas coming with these contiguous file allocation system, it's kind of an one sort of an file allocation mechanism, and as well as there are the other different types of allocation mechanisms too, like a linked allocation and as well as an indexed raw allocation. So the very first we're going to see this contiguous file allocation mechanism. So the very first thing is that we can see in the diagram we have one sort of a block of memory, like 0 to 34. There are the different sort of blocks of memory. Suppose we think that each block is like 500 bytes, and besides that there is a file allocation table, because as we previous slide which gives an information about FAT, it's nothing but file allocation table. Right now we can see it, this file allocation table consists of a file name, start block, and as well as length. So we're definitely going to discuss in this slide regarding these things, these attributes and these fields. And okay, let me first introduce this contiguous. In this contiguous file allocation system, the file, suppose if we take the file A, which is resides in the second, third, and the fourth blocks. The very first thing is when the file has been received, one third of the suppose if we take 1 KB, whatever maybe 1 KB of the memory file size. So the very first the file need to be get partitioned. So the first part of the file goes with the first block, and the next part of the file goes to the another block, which is next to the first block. So it's kind of a continuous process. For example, the file A has 3 blocks. So the very first thing is that the file A loads its half of the part into the more or less than half of the part into the second block, and the next third block and the fourth block. So totally the entire file has been saved into the hard disk. So here continuously the process has been done. Continuously the memory blocks has been allocated to the file. So here it's kind of a better because the contiguous file has a more advantage. Of course there are the each advantages and disadvantages for each allocation table, but whereas we can see the contiguous file allocation advantage, right now the IBM, like IBM VM or CMS operating system is presently right using this contiguous file allocation system, because if we want to jump from one sector to another sector, it's going to be taking a lesser seek time, whereas compared to like another sort of an file allocation algorithm. So this kind of a really advantageous thing. So even though there is an like advantages, there are few sort of issues. Before going to the few sort of an issues, let me discuss about this file allocation table. In this file allocation table, the name file name file A starts with the second block and has the length of the 3 blocks. That means that we have a start block address, the second block address, and we have the length. Because why we are storing the length? Because the start block, it's kind of a pointer, so the address is kind of a really big, so we don't want to waste such kind of a memory for using this contiguous. So the better came up with an idea of a length, because each length, so you need just has the length, and the start block is starting point address, that's it. So you can easily retrieve the data, because it's continuously processed, not a random process. Not the random files are not randomly stored in those contiguous file allocation system. So right now the issues with these contiguous file allocation system is that the external fragmentation and internal fragmentation. There are the two small issues which has a little bit drawbacks to these contiguous file allocation system. Right now we're going to discuss this external fragmentation. The external fragmentation, for example, the file A, if we take the file A, there is a 2, 3 and 4 blocks, the memory has been issued. Suppose if we want to, accidentally the third block has been totally cleaned off. The means the data has been gone in the third block, but the second and the fourth block still has the data. But the contiguous ideology is that the file need to be contiguously placed in these memory blocks. So here we have left with this third block, and it's never gonna be using this thing. So it's kind of an external fragmentation issues. And whereas coming with as an internal fragmentation issue is that this suppose if each block, we told, as I told before, each block has the size of 500 bytes. Suppose I have a file kind of consists of only 300 bytes, so the 200 bytes of memory has been wasted by issuing the complete block. So it's kind of an internal issues where you cannot retrieve that unless you have completed you cleared or deleted that totally block. So the thing here, we have seen that there are a few advantages and disadvantages as a contiguous file allocation, but it's kind of an better allocation mechanism, because as I told before, the IBM is right now one of the IBM OS is presently using this contiguous file allocation system. Now let us see the another file allocation mechanism is a linked allocation mechanism. We can compare this linked allocation mechanism with this like a linked list. In this linked list we have a data and as well as the pointer address which points to the next value. So in the same manner, the linked allocation mechanism is also saves the file in one sort of a location and has the address of another another block, which for example, if we take the block of 500 bytes, so in the 500 bytes we are going to issue 4 bytes of for address to the next pointing to the next memory block, and the remaining 496 bytes of data. So here we are trying to send the each byte, so one pointer, like we are going to send having a memory pointer, so that we're gonna be pointing to another block of the same file. For example, there is a zip file starting address is at 9, so we have maintained this to the directory. So the 9 is an present starting address point, so the 9th, so whereas the next given has 1 is the data and it has a pointer to the 16th value and the 16 pointer to 1. So different kind of it's kind of a running till it meets to the end point 25th block. So here we are maintaining in the directory the file system, the name of the file, and as well as starting and ending point. So and it's kind of a linked list. And there are the few sort of disadvantages, so whereas like jumping from one block to another block, and for example, as we talked before, 500 bytes and the 4 bytes has been allocated to only for the address pointer to the next block of the same file. It's a little bit issue of maintaining every sort of things. So it's kind of an so the seek time is kind of very large in this linked allocation mechanism, but it definitely solves one of the issues in contiguous allocation system, like that is nothing but an external fragmentation. The internal fragmentation is not yet solved in this linked allocation mechanism, but the external fragmentation is solved because we are going to use every sort of blocks by through these pointers helps. And right now we have seen advantages and disadvantages of linked allocation algorithm. Right now, let me introduce another person, an indexed allocation. In this indexed allocation, it is also one sort of an allocation algorithm. So it's basically used by the OA. So the thing here is that in the linked list, in the linked allocation mechanism, we are trying to save the data and as well as a pointer address to the next block. So but here it's kind of it's kind of indexed allocation are very easily implemented, because you have some sort of a file block, you have a file allocation table, and these file allocation table consist of an index block. So that is nothing but, suppose the file B has an index block of 24, so that this 24 has the every other block address pointers. So it's kind of a global thing. It's kind of easily we can understand this kind of an internet connection, because it's kind of a sitting hub is like a 24, and it's going to be sending the every sort of a signal to each and every sort of a node. So it's basically works in the similar fashion. So the thing is that here at the only the one point we are trying to store every other pointers which related to the file B, which those pointer locations of the file B. So this 24 consists of these details, and the remaining rest of the 1/8 block, third block consists of only the data. So it's kind of an abstract version, or like an linked list. So we don't need to maintain every block doesn't need to maintain 4 bytes of memory, doesn't need to waste it. So and also we can easily decrease the seek time by through this mechanism, so that we can easily we retrieve the data easily by using an indexed or allocation thing. So the same thing. So at the time of creating of a file, automatically the index block is created at a file type of when the file creation is started. So the thing is that the index block, the 24 goes within every sort of connected within every sort of blocks, and we are also having the length of those things. So that's it. So this is about an different sort of an allocations or allocation algorithms, and different sort of an allocation techniques and also this is about the file management system. So yeah, thank you so much, sir. Thank you.